day, learners at home. You are welcome to Ogun class. I am Fatai Soni. I will be taking you chemistry. And the topic for our discussion today is oxidation reduction reaction, otherwise known as redox reaction. There are so many industrial processes where oxidation reduction is very important, such as roasting of iron, purification of water, and extraction of metals. But for the purpose of this class, we are going to discuss oxidation reduction based on the following objectives. At the end of the class, the students or the learners should be able to define oxidation reduction. 2, the students should be able to define oxidizing agents and reducing agents. The students should be able to tell us tests to identify oxidizing agents and reducing agents. 3, the students should be able to define oxidation number and should be able to calculate the oxidation number of elements in an ion or molecules. And finally, the learners should be able to balance ionic equation. Now, how do we define oxidation reduction? Remember, oxidation reduction, I did not say oxidation and reduction. Oxidation reduction is a complementary reaction because for every oxidation reaction, there must be corresponding reduction reaction. In a given chemical equation, if you have oxidation, there must be corresponding reduction. The two reactions cannot be separated. Now, how do we define oxidation reduction? Oxidation can be defined as a process that involves addition of oxygen, while reduction is a process that involves removal of oxygen. That is one way. In another way, we can also define oxidation reduction in terms of hydrogen. Then oxidation is a process that involves removal of hydrogen, while reduction is a process that involves addition of hydrogen. In another way, we can also define oxidation reduction in terms of electronegative elements and electropositive elements. Then we can say oxidation is a process that involves addition of electronegative elements or removal of electropositive elements, while reduction is a process that involves removal of electronegative elements and addition of electropositive elements. But the most important of all this definition is in terms of loss of electron, that is electron transfer. Then we can define oxidation reduction in terms of loss of electron. Then we can say oxidation is a process that involves loss of electron, while reduction is a process that involves gain of electron. I will give a reaction to support all the definitions. So let's also look at this reaction. We say oxidation is addition of oxygen. If you look at this reaction, carbon becomes carbon dioxide because oxygen has been added. Then we can say this is oxidation. Then we have magnesium oxide coming to magnesium. If you look at this process, oxygen has been removed from magnesium oxide. That is why we have magnesium. Then we say this one is reduction. Remember we said oxidation reduction is a complementary reaction. In this type of reaction, we could say that both oxidation and reduction occur in this reaction. Now, if you want to explain in terms of hydrogen, we have another example. We have this is another example. We have hydrogen sulfide going to sulfur. What has happened? Correct. Hydrogen has been removed. They will say this process is oxidation. That is removal of hydrogen. Then we have chlorine coming to hydrogen chloride. What has happened to that process? Fine, hydrogen has been added. They will say this one is reduction. Now, you agree with me that oxidation reduction is a complementary reaction, because for every oxidation reaction, there must be complementary reduction reaction. Now, we'll move to oxidizing agent and reducing agent. Oxidizing agent is a substance which accepts or gains electron. They are otherwise known as electron acceptors. Example of the common oxidizing agents are acidified potassium tetraoxomanganate 7 and acidified potassium heptaoxodichromate 6. Then reducing agents. These are substances that lose or donate electron. They are otherwise known as electron donors. We have a lot of reducing agents in our laboratory. All metals are reducing agents. We have potassium iodide, we have iron 2 chloride, and so on and so forth. Then how do we test for oxidizing agents and reducing agents? Now, how do we test for oxidizing agent and reducing agent? Here we have if you suspect a substance to be an oxidizing agent, what you do is to look for a reducing agent. And if you suspect a substance to be a reducing agent, you look for an oxidizing agent. Now, how do we test for a reducing agent? I have here with me oxidizing agent. You can look at it at home. What is color of this solution? Yes, purple. This is acidified potassium tetraoxomanganate 7. If you suspect this solution to be a reducing agent, how do we conveniently say that this solution I have here with me is a reducing agent? Since I know this solution is an oxidizing agent, what I will do is that I will add this solution that I suspect to be a reducing agent to this my oxidizing agent. If there is change of color from purple to colorless, it shows that this solution is a reducing agent. Let's try it. Remember, the color of this solution is purple. I will say it is acidified potassium tetraoxomanganate 7. Let's add. What happens to the solution? It turns colorless. Then we can say this solution is a reducing agent. In other words, if you are to test for reducing agent, what you do is that you take an oxidizing agent like KMnO4, you add the reducing agent to it. If the solution changes from purple to colorless, then that solution is a reducing agent. Apart from, if instead of using KMnO4, we can as well make use of acidified potassium heptaoxodichromate 6. In that case, the solution will be changed from orange to green. Now, let's move to how do we now test for an oxidizing agent. Remember, when we tested for oxidizing agent, for reducing agent, we made use of oxidizing agent. If you are to test for reducing agent now, we are going to make use of a reducing agent. Now, how do we test for oxidizing agent? Now, what we do now is we'll make use of a reducing agent. Now, this is my reducing agent, potassium iodide. What is the color of this solution? You say it's colorless? Yes. Now, I will now look for an oxidizing agent to add to this reducing agent. If there is formation of brown solution, it shows that this solution is a reducing agent. Then let us add. Can you see? The solution turns from colorless to brown. It means this solution is a reducing agent. Learners at home, it is very important for us to carry out tests in chemistry. And when you have to describe a test, this is what you do. You must tell us this test before you tell us the observation. For example, we are testing for reducing agent. What we do is that you add a reducing agent to acidified potassium tetraoxomanganate 7. If the color changes from purple to colorless, then the solution is reducing agent. And if you are testing for a reducing agent, what we do is that you add a reducing agent, you add oxidizing agents to the reducing agent, like potassium iodide. If the solution changes from colorless to brown, then we can say the solution is reducing agent. Now, oxidation number. What is oxidation number? Oxidation number of an element in a molecule or ion is the electrical charge the element possesses as determined by a set of arbitrary rules. In other words, if we are to calculate oxidation number of elements in a compound or ion, there are some rules we must follow. For example, oxidation number of elements in a free state is equal to 0. That means when you have elements in an uncombined state, it has oxidation number of 0. For example, if I write Na, this is a free element. Its oxidation number is 0. Or I write K is also a free element. Its oxidation number is equal to 0. 2. Oxidation number of ion is the electrical charge we have on the ion. For example, we have this is sodium ion. The oxidation number of sodium here is +1. Or I write H2 minus. The oxidation number of sulfur here is -2. 3. Sum of oxidation number of elements in a compound is equal to 0. That means in a compound where we have more than one element, if we add the oxidation number of the elements together, it will give us 0. But in a radical ion, what do we mean by radical ion? A group of atoms that act as an entity and possess electrical charge is called radical ion. In that case, sum of the oxidation number of elements there is equal to the charge on the radical. But for convenience, in most compounds, we have hydrogen. So the oxidation number of hydrogen in many compounds is equal to +1, except in anhydride. Anhydride is when you have hydrogen after a metal. Then also, oxygen has oxidation number of -2, except in a peroxide. Now, let us look at an example of how we do calculation on oxidation number. We are going to have a break now, and when we come back, we are going to continue with the oxidation number. You are welcome back. Before we went on break, we were looking at oxidation number. And I've told you the rules for calculating oxidation number in an ion or a compound. Now, let us look at an example here. Calculate the oxidation number of sulfur in the following compounds or ions. We have H2SO4, 2SO3, 2 minus, then SO2. Let's look at our solution. This is a compound. It's a neutral compound. Now, we have said that the oxidation number of hydrogen in compound is equal to +1, except anhydride. This compound here is not anhydride. So it means the oxidation number of hydrogen here is equal to 1. But there are 2 atoms of hydrogen. So it means 1 times 2 plus, since we don't know the oxidation number of sulfur, we use S to represent that sulfur, that is plus X, plus We also said that the oxidation number of oxygen is equal to -2 in all compound except in a peroxide. This compound is not a peroxide. That means oxidation number of oxygen is equal to -2. But there are 4 atoms of oxygen. So that is why we have -2 times 4. Sum of oxidation number of elements in a compound is equal to 0. That is why the sum of all the oxidation numbers of elements in that compound is equal to 0. 1 times 2 will give us 2 plus x. -2 times 4 will give us -8. Everything gives us 0. Then we can say x is equal to s minus 6 is equal to 0. So we have said x minus 6 is equal to 0. Then x will be equal to plus 6. Learners at home, it is very important here to write the charge. This is not mathematics where you say plus is not relevant. Plus here and minus is very relevant in oxidation number. Remember we said the definition is the electrical charge. What it makes charge is the sign. So the oxidation number of sulfur is equal to plus 6. Then the next one is SO3 2 minus. This is a radical ion. Remember we want to calculate the oxidation number of sulfur. Then we'll say X plus, what is the oxidation number of oxygen? Yes, correct, -2. We have -2 times 3, because there are 3 atoms of oxygen, is equal to, this is the radical ion. The sum of oxidation number of elements here will be equal to the charge on the ion, is equal to -2. Then we can say x minus 6, because -2 times 3 will give us -6, is equal to -2. Then x is equal to -2 plus -2 plus 6, and this will give us plus 4. That means oxidation number of sulfur in that ion is equal to plus 4. Then the third one, we have SO2. That is x plus -2 times 2, because oxidation number of oxygen is equal to -2. This is a neutral compound. That should give us 0. Then we have x minus 4 is equal to 0. Then we can say s is equal to plus 4. Make sure you write the charge, otherwise you have 0. Now, what are the importance of oxidation number? What are the importance of oxidation number? Number 1, it is used for naming compound. Have you imagined when you're asked to write or state the name of H2SO4? What do you say? Hydrogen tetrad oxosulfate 6. Where do you get the 6? Oxidation number of sulfur. That is why oxidation number is very important in naming compound. Number 2, it is used to balance ionic equation. We are going to look at this use in due course where we go to balancing of ionic equation. Now, how do we balance ionic equation? If you have to balance ionic equation, the rules you follow are the following. Number 1, break the equation into 2 halves. One for oxidation half equation, the other one for reduction half equation. 2, balance each half. 3, ensure that electron loss at oxidation half equation is equal to the electron gain at the reduction half equation. Therefore, add the 2 half equations to obtain the balanced ionic equation. So simple. Let us have one example and see how we are going to balance the ionic equation. Here we have balance the following ionic equation in acidic medium. We have MnO4 minus plus Fe2 plus to give us Mn2 plus plus Fe3 plus. How do we go about this? Now, the question is MnO4 minus plus Fe2 plus to give us Mn2 plus plus Fe3 plus. The first step is to break the equation into two halves. The first equation is going to give us MnO4 minus giving us Mn2 plus, because we know that manganese cannot give us ion 3. Then we have Fe2 plus giving us Fe3 plus. We have broken the equation into two halves. Reduction half equation, oxidation half equation. Let us balance each of the half. How do we balance each of the half? The first thing we'll do in balancing the equation is just to balance the atom. Here there are 4 oxygen atoms, no oxygen atom here at all. How do we balance it? Since the equation in acidic medium, what we use to balance oxygen is hydrogen ion and water molecule. Therefore, where we have excess oxygen, to one excess oxygen, we are going to add 2 protons. That is hydrogen ion. It means here we are going to add 8 hydrogen ion because there are 4 oxygen atoms in excess. Then we have plus 8 H plus. Then the other side of the equation, we are going to balance with 1 molecule of water to 1 oxygen atom. How many water molecules are we adding at the right-hand side? 4, correct. Then we have plus 4 H2O. The equation is not still balanced because we have only balanced the atoms. It remains the charges. Here we have minus 1 on MnO4 minus. We have plus 8 on hydrogen ion, making total of minus 1 plus 8 will give us plus 7. The only charge we have at the right-hand side is only plus 2. What is the difference between the charges? Plus 5. Correct. Electron must be used to balance that equation. Here we are going to write 5E minus. Then we'll come to the oxidation half equation. Here we have ion 2 going to ion 3. The atoms is balanced. It's only the charge. The charge you have here is plus 2. The charge you have here is plus 1. That is the difference of 1 electron. That means we are going to add electron to this side. 1 electron. For us to combine the two halves, the number of electron loss must be equal to the number of electron gain. Here we have 5 electron gain. We have 1 electron loss. What do? We still remember our simultaneous equation. We want to eliminate electron. That means we have to multiply the reduction half equation here by 5. So we have times 5. So this becomes 5Fe2 plus to give us 5Fe3 plus plus 5E minus. The electron loss cancel electron gain. Then the last one now is for us to combine the two halves. Write the equation at your left-hand side together, then combine the one as you have at your right-hand side together. Then we have MnO4 minus plus 5Fe2 plus plus 8 plus to give us Mn2 plus plus 5Fe3 plus plus 4H2O. You can always check your answer if it is right or not. You look at manganese is 1, manganese is 1. There are 4 atoms of oxygen. There are 4 atoms of oxygen. We have 5 iron. We have 5 iron. Then we have 8 hydrogen. We have 8 hydrogen. Remember, we say we use oxidation number to balance ionic equation. Here, let us look at the charge we have at the left-hand side. -1 plus 10, then plus 8. So the charge here is equal to the charge we have here. Viewer at home, take this assignment. Balance the ionic equation. We have MnO4 minus plus NO2 to give us Mn2 plus NO3 minus. Solve this equation and submit to our website www.ogundijeclass.ng. I remain Fatai Sonny. Thanks for watching.